Alright, so we're going to look at the first part of inverse functions, and it's actually going to be two different lessons on inverse functions. First of all, we're going to learn how to identify if functions are inverse, and that's what are inverses, and that's what this lesson is about, is identifying inverse functions or inverse relations. An inverse relation just means that you have a set of ordered pairs where the input and output are switched, I'll say it that way, to obtain a new relation. So all I'm saying is this: when you have a particular relation or a set of ordered pairs, in order to get the inverse, you just switch the x and y values. If this is my original, then my inverse is going to have the x's and y's switched. Instead of having the ordered pair 3, 1, it's going to have an ordered pair 1, 3. 5, 1 becomes 1, 5. 7, 1 becomes 1, 7. You just change the order of the x's and the y's. So if I give you a table and I ask you to find the inverse of this relation, you just switch the x and y values. Sorry, that should have been a 4 and that should have been a negative 2. 2, negative 1, 0, 0, 2, 1, and negative 4, 2. That's all you do to find an inverse relation from a table. From a set of ordered pairs, you do the same thing. You just switch the x's and the y's. We're going to write it in that set notation because it is a set of ordered pairs, and my ordered pairs now become negative 1, 6, 4, 1, 3, 2, and 1, 6. And that's my inverse of my original relation, of my original set of ordered pairs. So this becomes 4, negative 2, 3, 1, 2, 5, and 4, 1. Close it up with my brackets. Your curly brackets don't have to be perfect because mine aren't either. So you do 3 and 4 and then check it with me. There we go. Just finding an inverse relation, you just switch the x's and the y's. So the other thing we're going to do on this set is verify that two functions are inverses. And that's where we're going to use that function composition that we just did. When you compose two functions, that means you put one function into another. The input of one function becomes the output. Sorry, I said that backwards. The output of one function becomes the input of the other function. Well, if you have functions that are inverses, and you do that, when you put g into f, and you put f into g, then your output for both functions is just going to be x. So if both compositions are equal to the input, which is x, then they are inverses. But if they do not equal, when you do that composition, if it does not equal x, when you simplify it all the way down, then they are not inverses. So it's just doing composition, simplifying it to see what you get. Some of them are a little bit tough. I'm not going to lie to you and tell you that they're not. But it's just composition, order of operations, simplifying it as much as you can. So let's look at these examples on this side. If I do f of g, and here's the thing about this. When you do f of g of x, if you don't get x for your final answer when you do your order of operations and you simplify it, you don't have to do the other composition because it doesn't matter. It's got to be, when I do this composition, if it equals x, then I need to do g composed with f. If I do f composed with g and it does not equal x, then I'm finished. They are not inverses. So f of x is 2x plus 4, and we're going to plug in, for my people that might still be having trouble, I'm going to use two separate colors here. I'm going to plug in, and this has a typo. That should have been 1/2 x minus 4. So fix that for me. So now I'm just going to simplify that. So 2 times 1/2 x, or 1/2 of 2 is 1, so that's just x. 2 times negative 4 is negative 8. And x minus 8 plus 4 is x minus 4. This does not equal x, so these are not inverse functions. That's all you're doing. You do the composition. If it equals x, then you do the other composition and verify that they both are x when you simplify. If it's not x, you're finished. They are not inverse functions. Look at number 2. I've got f of x equals x plus 7, g of x equals x minus 7. If I do f of g of x, then I do x plus 7, and I plug in x minus 7. If I do my order of operations here, I can just get rid of the parentheses, and I get x minus 7 plus 7, which is just x. Okay, so that means I need to check the other direction. I need to do g of f of x. And g of x is x minus 7, and I'm going to plug in x plus 7. I'm just doing composition. So that's x plus 7 minus 7, which equals x, and so f and g are inverses. When you do the inverse, when you do the composition and they both equal x, then you have inverse functions. Okay? Look at number 3. If you want to do this by yourself, then pause the lesson and do it by yourself and then check your answer, if you think you're ready to branch out on your own. But make sure you come back and check your answers. So I'm going to do f composed with g. Sorry, all these parentheses get me confused. So f of x is negative 2x plus 4, and I'm going to plug in negative 1/2 x plus 2. So I'm going to distribute my negative 2. Negative 2 times negative 1/2 x gives me a positive x. Negative 2 times 2 gives me a negative 4 plus 4, and that's 0, so this is x. So now, since this is x, let's check the other composition, g of f of x. So g of x is negative 1/2 x plus 2, and I'm going to put in a negative 2x plus 4. Do my order of operations. The only thing I can do first is distribute that negative 1/2. So negative 1/2 times negative 2x is a positive 1x. Negative 1/2 times 4 is negative 2 plus 2, and negative 2 plus 2 is 0, so that's x. So f and g are inverses, because when I do the compositions of the two, put g into f, put f into g, I get x both times. That means I have inverse functions. We'll talk more about the graphing stuff together and not on a video, so you can see what inverse functions look like. So let's look at number 4. Again, if you want to do it without me and then check back and make sure your work is right, please do that so that you can feel confident in what you're doing. If you're not quite there yet, then stay with me. So I'm going to do g composed with f. And that's going to be, now it's a fraction, but it's okay. We're just going to do x minus 5 over 8. And then we're going to plug in the 4x minus 4. So see, that's not really all that bad. So if on the top, the only thing I can do is get rid of those parentheses and combine like terms. So I've got 4x minus 9 over 8. There is absolutely nothing I can do to that to simplify that. That is, g composed with f of x is 4x minus 9 over 8. If it does not simplify down to x, there's no need to do the other composition. These two are not, sorry, inverses of each other. Woo, Lordy. Me and my hand and my brain, we're not working together. Not inverses, because this is not x. I can't simplify it down to x. Alright, let's look at number 5. It's a fraction again, but still, it's not bad. And I'm going to tell you this, if you don't want to do, I'm going to write in pencil right here if I don't have one, of course. I thought I had a pencil up here. I'm going to do it here, just so you can see. You know, if we do this, if I have to do g of f, just watch for a second. If I do negative n plus 2, and I plug in this, and I'm not really sure how to deal with that, then do the other one first. Do f of g of n. And that just gives me 5n minus 13 over 2, and then I'm plugging in the negative n plus 2. And that's a little bit easier, actually, that's a lot easier to deal with, because you've got one fraction trying to simplify it instead of trying to add a fraction to a whole number and then simplify that. So I've got distribute the 5, so I have negative 5n plus 10 minus 13 over 2. And so that's negative 5n minus 3 over 2, which there's nothing I can do to that to give me x, so not inverses. And then the last one, number 6, I've got f of x is x squared plus 5, g of x is the square root of x minus 5. I'm looking ahead, and this is what you'll get more comfortable with. If I do this into here, then I'm going to have to square that. I'm going to have to do x minus 5 times x minus 5. Or I could put this in here. If I do g of f of x, then I've got the square root of x squared plus 5 and the minus 5 on the outside. And so then you just look at that. Can I simplify that? Can I take the square root of x squared plus 5? And the answer is no, because I can't. Here's what you can't do. Please don't do this. I'm telling you, this is a big fat no right here. You cannot do this. You can't separate a square root with addition that's inside. And so there's absolutely nothing I can do to this to simplify it. Not inverses. That's it. That's all there is to it. So there's your lesson. We'll get some work on that, and then we're going to learn how to write inverse functions. Start with a function and identify what its inverse is.